Now it's your time to give it a try. For this problem, take a minute to read the problem and take a look. Try to do this problem before you continue the video. Whenever you're ready, we're going to continue on. And in this case, we have a problem that's similar to what we did in the example. So what we're going to do is, again, we can start off by defining the variables we have. And here I'm just going to go ahead and let x and y be our variables. Feel free to choose whatever letters you like to define the variables. So we can say let x be the horizontal distance. The arrow has traveled in feet, and y be the height above the valley floor. And once we define the x and y as the variables, again, we want to have this in feet. Once we have this defined, we can go ahead and translate the statements and conditions in the question into coordinates. And the first point we have is when it was first shot, it's 100 feet above the valley floor. So we would get 0, 100 as our starting point, because when it was first shot, there was no horizontal distance traveled and the height was 100. And on the other condition, we have the max height is 300 feet when it's 160 feet away. So we can get the vertex is going to be 160, comma 300 over here. So right away, when we want to write out the vertex form of the equation, we can start off saying y is equal to some leading coefficient a times x minus 160, which comes from the horizontal coordinate of the vertex, and plus 300, which is a vertical coordinate of the vertex. And then in order to find a, we want to use a point 0, 100, our y-intercept, in order to find what exactly our a value is. So go ahead and we can plug 100 into y. While we don't know a, we know at that point x is 0 minus 160 squared plus 300. And to calculate this, we can subtract 300 on both sides. Negative 200 equals negative 160 squared. We would get 25,600, a. And to find a, we can go ahead and divide away that to 25,600. And simplifying things a little bit, the zeros cancel out. That's a factor of 100 that can be canceled out. And 2 and 256 again have a factor of 2 shared in common, so we should reduce it to negative 1 over 128 equal to a. Therefore, we get our equation is negative 1 over 128 times x minus 160 squared plus 300. And that's going to be our vertex form already. Now to create this graph, we want to find enough points so we can create a precise graph of the path this ball traveled. So already we have the y-intercept, we have the vertex, so we can find the mirror point of the vertex of the y-intercept. So for the mirror point, we know it's the same height as the y-intercept, so y-coordinate should also be 100, and on the horizontal distance, it should be double the x-coordinate of a vertex. So 160 plus 160 becomes 320. And that's a mirror point we can use. And we can also find the horizontal intercept, and that also helps us answering the question as to how far the arrow would have traveled when it hits the ground. So to find this, we want to find the x-intercept. So for x-intercept, we can set the y-coordinate to be equal to 0. And that's equal to negative 128, negative 1 over 128 times x minus 160 squared plus 300. To solve it, we want to isolate the perfect square by itself to use a square root method. That gives us negative 300 equals negative 1 over 128 times x minus 160 squared. To isolate the perfect square, multiply the negative 128 on both sides. That would give us a positive 37,600 on the left hand side, equal to x minus 160 squared, like this. And sorry, not 376, but 384. Then 0, 0. Over here on the left side, now if we want to calculate it, we want to take the square root again on both sides. And here, again, if you think about the path of the arrow, technically a parabola should have two x-intercepts, but because the arrow is shot off the way above the ground, that means we would have the other x-intercept, or one of the x-intercept would have the horizontal distance below 0. And in that case, it wouldn't make sense in our context, so we would only want to take the positive value over here. And once we take the square root, we would get x minus 160. And for square root of 384, 38,400, we want to again go through the factoring process a little bit. So for 384, I'm going to do it offside over here. This is equal to 100 times 384 to start, and 100 is already a perfect square number, so I can leave it as is. And for 384, we can go ahead and think about what are the factors that go into this. I believe a 4 will be a factor, so 384 divided by 4 will be 96 in this case. And once we have 96, that can be divided further into 4 times 24 over here, and 24 again becomes 4 times 6. So altogether, we can combine things a little bit to say 38,400 is equal to 100, which is 10 squared, times here we have two factors 4 we can group together. So this is equal to 4 squared times the leftover 4, which is also a perfect square number, which is 2 squared, times 6, which cannot be factored into any other perfect square factors. So here are what we get. If I want to simplify this, that becomes square root of 10 squared times 4 squared times 2 squared times 6. And anything that's a perfect square I can take out of the radical. So that becomes 10 times 4 times 2, then square root of 6 equals x minus 160. And altogether we get 80 root 6 equals x minus 160. And to find x, add 160 on both sides. That's equal to x. And for the same reason as before, we want to go ahead and simplify this number so we can use the estimate value to graph. And here we have square root of 6 to start with. And we can multiply this by 80, then add 160. So altogether we get about 356 feet. And we can use this answer to complete the question as well, to say the arrow would have traveled this much horizontally in feet horizontally before hitting the ground or the valley floor. And that also tells us we can have the x-intercept given, which is 356, 0. and that's the approximated value, but that's going to be more helpful for us to graph it. Next, we want to find 2 points that would be plotted on the graph to make a more concise curve. And you can pick any x-coordinate, again, to find the corresponding y value. And I'm going to pick the points that's in between the points that we already have. So between 0 being the x-coordinate, the next point is 160. So I'm going to pick x equals 80 to be the point. So when x equals 80, we get y is equal to negative 1 over 128 times 80 minus 160 squared plus 300. And you can use a calculator to go through this process over here. You will get negative 50 plus 300, which is 250 feet. And to find the mirror point, we can again use a quick sketch. We have the point 80 to 50, and the vertical line we have for the x of symmetry is x equals 160. So the horizontal distance should be exactly 80 units. So 160 plus 80 will be 240, and the vertical coordinate will be the same as the other point, 250. So these are the additional points we want to include. And here, just to look through this whole process, we want to have the x-axis include values from 0 to 356, and the vertical direction should include everything between 0 and 300. So I'm going to take a minute to create the coordinate plane and scale it accordingly. These points over here, and with this information we can say this is a path the arrow traveled through. And notice, don't extend on either side with an arrow, because normally when we graph a parabola we want to draw arrow on both ends to indicate it continues going, but in this case, once the arrow hits the ground, it stopped moving, so the path stops here. And same with the beginning, that's where it started, there's no path that's before it was shot out.